Characteristics of integrated science. Integrated science is characterized by its innovative approach to organizing and delivering scientific education. Unlike traditional subject-based curricula, integrated science breaks down the barriers between disciplines, offering a cohesive and interconnected learning experience. This approach emphasizes thematic organization, where scientific concepts are unified around central themes, such as energy, life, mind, and society. Hence, integrated science is characterized in terms of interdisciplinary approach, holistic perspective, relevance and application, critical thinking and problem solving, and educational outcome. Integrated science is characterized in interdisciplinary approach. When we say interdisciplinary approach, it is the breaking down of subjects' boundaries to promote cross-disciplinary understanding. This approach benefits from integrating multiple scientific disciplines such as biology, physics, and chemistry, and it explores practical application of interdisciplinary knowledge in real-world context. And we have the second one as holistic perspective. Integrated science can be characterized as holistic perspective. Understanding the interconnectedness of scientific concepts and phenomena, integrated science fosters a holistic view of science and its importance in addressing complex scientific and societal issues. It addresses complex scientific and societal issues. And we have the third one to be relevance and application. Integrated science can be characterized in the form of relevance and application. Integrated science encourages students to apply scientific knowledge to real-world problems and demonstrates how it promotes relevance and practicality in education. Integrated science can also be characterized into critical thinking and problem solving. It emphasizes inquiry-based learning and hands-on activities to develop critical thinking skills. This approach cultivates problem-solving abilities necessary for addressing future challenges. And we have the fifth one to be educational outcomes. Integrated science can also be characterized in the form of educational outcomes. It impacts students' learning outcomes by developing skills and competencies essential for scientific careers and informed citizenship. Educational outcomes highlights the long-term benefits of integrated science in preparing students for complexities of the modern world. Science, technology, engineering, and mathematics. STEM. What is STEM? STEM simply stands for science, technology, engineering, and mathematics. Science, technology, engineering, and mathematics are interrelated and interwoven bundle of knowledge that forms the ingredient for integrated science breakthrough. You see here, this is a typical example of integration of scientific process and science products. Take for instance, science studies the flow of electronics in electrical conductors by using already existing tools and knowledge. This found knowledge is used by engineers to create new tools and machines such as semiconductors. This new formed knowledge can also be used to construct computers and other forms of advanced technologies. In this sense, both scientists and engineers are considered technologies. STEM education builds in individuals in varying proportions, while the scientist explores what is, the engineer creates what has not existed before, and the technologist translates ideas and plans into working realities, aware of his or her responsibility and duties towards the society. STEM education brings about the integration of ideas that gives rise to new products. STEM is also a typical process of integration of scientific ideas to yield the expected result for human development. So wherever you hear STEM, it is the process of integration of scientific ideas to yield the expected result for human development. The integrated science teacher should always work towards integration of science knowledge while teaching basic science and technology. Method of teaching integrated science. In teaching integrated science, we have different kind of methods we can employ to teach integrated science, among which are guided inquiry. Guided inquiry is a teaching approach where the learner carries out the learning activity with the teacher as a guide. The learner from experience builds up the knowledge. The learner is also in control of what they learn or what he or she learn. Inquiry method can be applied in teaching all basic science and technology topics. And we have the activity-based approach also. When we say activity-based approach, in teaching integrated science centers on inquiry and hands-on learning. In teaching integrated science, it centers on what? Inquiry and hands-on learning experience. It places the learner at the forefront of the educational process, thereby actively engaging them in discovering solutions to problems. And we also have the project method. Here, it is a recommended approach for teaching integrated science. It emphasizes student-centered and inquiry-based learning. You see, project method provides learners with opportunities to apply theoretical knowledge to real-world situations. It also promotes practical application and problem-solving skills. And we also have the laboratory method. The laboratory method is an activity-packed method for group or individual learners, targeted at making personal observations of process, products, or events. You see, the laboratory method can either be laboratory exercise or laboratory experiments. Most importantly, all laboratory exercises are experiments, but not all experiments are laboratory work. Laboratory method of teaching integrated science is adequate for illustrating scientific principles, laws, as well as inculcating in students how to write laboratory reports. The laboratory method of teaching integrated science provides students opportunity to develop manipulative and practical skills. Which brings us to what we call the next one, field trip. Field trip is one of student-centered inquiry-based approaches adopted for the teaching of integrated science. It involves educational excursions to various locations outside the classroom. We move from one place to the other, but outside what? The classroom. It allows students to make first-hand observations and gather specific information in original conditions or natural form. Field trip brings learners closer to real-life situations. It promotes closeness, group work. The learners come together in real-life situations. Additionally, field trip also promote teamwork, like I have earlier explained. It leads to collaboration among students. When we have criteria for selecting teaching method for a topic. In selecting a teaching method, we have to consider some certain things, of which age of the learners or students, pupils is there, nature of the topic, you should consider it, competence of the teacher should be considered, size of class should be considered, availability of resources should be considered, time for teaching should be considered. So let's start by explaining age of the learner. Age of the learner is the physical and mental development of learners significantly impacts. Age of the learner, this is what the physical and mental development of learners, it significantly impacts the choice of teaching method. Younger learners, for instance, may benefit from hands-on activities and visual aids to facilitate understanding and retention, whereas older learners might engage more deeply with theoretical concepts and advanced discussions. Older learners. Which brings us to another area you consider when choosing teaching method for a topic: nature of the topic. We have nature of the topic. You should note that not all topics can be effectively taught using the same teaching method. The nature of the topic, whether it involves abstract concepts, practical skills, historical events, or scientific principles, should guide the selection of an appropriate teaching method. Take for instance, complex scientific theories might require experiments and demonstrations, while literature analysis may necessitate group discussions and critical thinking exercise. Then we have another thing we consider, which is competence of the teacher. You need to consider the competence of a teacher, or a teacher needs to consider his or her own competence before choosing a method of teaching. The teacher's familiarity and proficiency with different teaching methods play a crucial role in method selection. Teachers should choose methods they are comfortable with and capable of using effectively to enhance students' learning. This will ensure clarity in instruction and the ability to provide meaningful guidance and support. And we have class size also as what you consider in choosing teaching method for a topic. Size of the class. The number of students in the class influences the choice of teaching method. Large classes may require methods that promote active participation and interaction to maintain engagement and manage, the classroom effectively, while smaller classes, on the other hand, may allow for more personalized individual attention and can accommodate methods that encourage in-depth discussions and individual feedback. We have availability of resources also as what you consider in choosing a teaching method for a topic. Resource availability. The availability of resources such as teaching aids, technology, laboratory equipment, textbooks can impact the selection of teaching methods. Methods that require specific resources such as multimedia, presentations, or hands-on experiments can enhance learning experience when adequately supported by available resources. Lack of resources may necessitate creative adaptation of teaching methods, that is improvisation, or prioritization of alternative approaches. We also consider time for teaching. Yes, the allocated time for teaching. The scheduling of the topic within the academic timetable influences the selection of teaching methods. Consideration should be given to the amount of time allocated for teaching the topic, as well as its position within the broader curriculum. Methods that require extended periods for practical activities or discussions may need to be adjusted to fit within the recommended or designated time slots while ensuring comprehensive coverage of content. Which brings us to the end of today's class.